Elon Musk's Starship won't save astronomy from satellites cluttering the sky. Good day, ladies and gentlemen. In today's video, we will be discussing Elon Musk's Starship and its potential impact on the astronomy community. Elon Musk, the founder and CEO of SpaceX, has been making waves in the space and technology industries for years. One of his most ambitious projects is the development of the Starship spacecraft, which he envisions as a means of facilitating human exploration and colonization of Mars. However, his plans for satellite constellations to provide internet connectivity around the world have raised concerns among astronomers who fear that the proliferation of satellites will clutter the night sky and interfere with scientific research. This article explores the impact of satellite constellations on astronomy and the challenges faced by astronomers in mitigating this impact. Introduction to Elon Musk's Starship and satellite constellations. Elon Musk, the CEO of SpaceX, has brought us the Falcon Heavy, reusable rockets, and now, the Starship. This mega-rocket is designed to carry humans to Mars and beyond. However, Musk's company is also heavily invested in satellite constellations, which has raised concerns among astronomers. Overview of Elon Musk's Starship and plans for satellite constellations. SpaceX launched the first 60 Starlink satellites in May 2019 as part of its plan to provide high-speed internet to the entire planet. The company aims to launch thousands of satellites into low Earth orbit. Similarly, other companies are also planning to deploy satellite constellations for communication, navigation, and Earth observation. Impact of satellite constellations on astronomy. Introduction to the impact of satellite clutter on astronomy. Satellite constellations pose significant problems for astronomers and astrophotographers. The movement and reflection of satellites can interfere with observations, contaminating ground-based telescope images with streaks of light. This interference can also affect scientific measurements of cosmic objects, such as star brightness and redshift. Discussion of specific impacts on astronomy research. Satellite constellations can interfere with observations of celestial objects, such as comets, asteroids, and other important research targets. Additionally, the impacts of satellite clutter can negatively affect the scientific community's understanding of the universe, such as by inhibiting research and discoveries within the field of astrophysics. Challenges faced by astronomers due to satellite clutter. Difficulties in observation and data collection. Astronomers are facing rising difficulties in obtaining quality data for research due to satellite clutter. The movement of satellites and their reflections can be unpredictable, making it difficult to remove them from images and other data sets. This interference can result in increased uncertainties and errors, ultimately making some research outcomes less reliable or even unusable. Issues with light pollution and interference. Satellite constellations can also contribute to light pollution, which can hamper astronomical observations. The reflected light can interfere with the observations of light-sensitive equipment, such as radio telescopes. Additionally, using filters to block satellite light can reduce the amount of light captured by the telescope, ultimately reducing the research yields. Solutions proposed by astronomers to mitigate the impact. Overview of proposed solutions. Astronomers have proposed various technical and legal solutions to mitigate the impact of satellite constellations. Some technical solutions include modifying the satellite's brightness and reflectivity, changing the satellite orbits, altering the timing of launches, and using software to filter out satellite interference. Meanwhile, policy and legal solutions may include creating agreements that limit the number of satellites, enforce different launch sites, and impose regulations on satellite operators. Discussion of technical solutions. Astronomers are also exploring technical solutions that could reduce the impacts of satellite constellations on scientific research. For example, using satellites with passive or adaptive optics to reduce brightness and reflection could improve the quality of astronomical observations. Similarly, optimizing the launch sequence, timing, and trajectory could help reduce clutter and its impact on observations. Discussion of policy and legal solutions. While technical solutions can address some of the challenges, regulatory and policy solutions may be necessary for satellite constellations' long-term management. Policymakers could require satellite operators to use different orbits, limit the number of satellites, or observe limits on the brightness of the satellites. Additionally, requiring satellite operators to share data with the scientific community could also help mitigate the impacts of the satellite constellations on scientific research. Elon Musk's response to astronomical concerns. Elon Musk's SpaceX has been launching Starlink satellites in batches of 60 since May 2019, with a total of over 1,500 satellites currently orbiting in low Earth orbit. However, astronomers have expressed concerns about the negative impact of large-scale satellite constellations on their ability to observe the night sky. In response to these concerns, Elon Musk has acknowledged the issue but has not fully addressed the concerns of astronomers. Overview of Musk's response to astronomical concerns. Musk has responded to astronomical concerns by stating that the Starlink satellites are equipped with sunshades and that SpaceX is working on reducing the reflectivity of the satellites to make them less visible to telescopes. He has also suggested that the benefits of Starlink, such as providing high-speed internet to rural areas, outweigh the downsides. Assessment of the adequacy of Musk's response. While Musk's response acknowledges the issue, it does not fully address the concerns of astronomers. The sunshades are only effective at certain times of the day, and reducing the reflectivity of the satellites may not be enough to mitigate the impact on astronomy. Furthermore, the benefits of Starlink should not come at the cost of scientific research. The future of astronomy with satellite constellations. Estimated future impact of satellite constellations on astronomy research. The launch of large-scale satellite constellations like Starlink poses a significant threat to astronomy research. The satellites can cause bright streaks in astronomical images, making it difficult or impossible to observe some areas of the night sky. The effect of the satellites on ground-based astronomy will be more severe than space-based astronomy. Discussion of possible solutions and mitigation strategies. There are several possible solutions to mitigate the impact of satellite constellations on astronomy research. One solution is to limit the number of satellites launched and to reduce their reflectivity to make them less visible to telescopes. Another option is to use software programs that can remove satellite streaks from astronomical images. Collaboration between satellite operators and astronomers is essential to find mutually beneficial solutions. Conclusion and the road ahead for astronomy and satellite technology. Summary of findings. The launch of large-scale satellite constellations like Starlink has raised serious concerns among astronomers about the negative impact on scientific research. While Elon Musk has acknowledged the issue, his response has not adequately addressed the concerns of astronomers. Moreover, the benefits of satellite constellations should not come at the cost of scientific research. Discussion of possible future developments and collaborations. It is essential to continue the discussion between satellite operators and astronomers to find solutions that work for both parties. Possible collaborative efforts include developing better observational tools for astronomers and working on reducing the negative impact of satellite constellations on the night sky. While Elon Musk's Starship may not save astronomy from satellite cluttering the sky, collaboration can lead to win-win solutions for both industry and science. As the number of satellites in orbit continues to grow, it is important for the astronomy community and satellite industry to work together to find solutions that address concerns about the impact of satellite clutter on scientific research. While this is a complex issue, it is clear that collaboration and innovation will be key to ensuring that both the scientific community and the satellite industry can thrive in the coming years. In conclusion, while the Starship may be a significant technological advancement in space travel, it may not solve the problem of satellite clutter. The key is to reduce the number of satellites in orbit and ensure that they are less disruptive to astronomical observations. By doing so, we can preserve the valuable work of the astronomy community and continue to push the boundaries of human knowledge and understanding. Thank you for tuning in. Thanks for watching.